here's a vector. It represents a quantity like position, displacement, velocity, acceleration, or force, something that involves space. There are several ways we can represent vectors. One is an arrow on a screen. The other is in terms of an ordered pair, which are the components of the vector, which are projections of the vector along two axes. So this particular vector, called A, could be represented by an ordered pair. The x value is 20, and the y value is 5. In this course, most of the vectors we deal with are going to have units. So if this was a position vector, it could be 20 meters, 5 meters. Now there's another notation that's convenient to use that we use a lot for vectors, and that is we'll write this as 20 x hat plus 5 y hat. This means exactly the same thing. This x hat represents a unit vector of length 1, a vector of length 1 in the x direction. Let me turn this into a unit vector. So this here is what I hat is. Okay? And if I take 20 of these, I get this dashed line here. And then I can take y hat as a unit vector, a vector of length 1 in the y direction. And if I add 20 of these guys to 5 of those guys, I get my original vector. So that's the origin of the notation. This is just a convenient way to write things. And I'll show you why it's convenient in a second. As an aside, there are two conventions for this unit vector notation. The first one uses x hat and y hat, as we did here. The second uses I hat and j hat. That is, we write, instead of 20 x hat plus 5 y hat, we would write 20 I hat plus 5 j hat. These are completely equivalent. X hat means the same thing as I hat, and y hat means the same thing as j hat. The Nexus textbook uses I and j. I tend to like x and y. I think it's more clear. Now, a vector in our graphical representation is unchanged if I move it around. So if I put the vector here, it's the same vector as if I moved it here. If you look at its components, the components are unchanged by moving it around. And we use the same mathematical description no matter where it is. One common thing you'll need to do with vectors is add them together. So if I take two vectors, the way to add them is I put the tail of one, the tip of the other, and then their sum is the vector that goes from the tail all the way to the tip. Now, we could do this sum in a different way. I could take B and then put the tail of A on B, and I'll get exactly the same vector. In practice, in most calculations, we add vectors by using their components. So if I look at the x component of A, which is B, which is 10, and the x component of A, which is 20, when I add those together, I get 30, the x component of their sum. Similarly, I just add the y components to get the sum. In other words, if A is equal to 20x, 5y, and B is equal their sum, I just get by adding components. The other thing you might want to do is take the difference between two vectors. Well, just as you add vectors by adding the components, you'll subtract vectors by subtracting their components. There's a geometric construction for that when you subtract, they call this vector C. That vector is the vector that you add to B to get A. So if I put A down here, and I pull out C, that C must be A minus B. And one technique is for calculating C, indeed, is you put these two vectors base to base. The final important thing about vectors is how you relate the components to the angles. And this is just something you have to remember. So if I have a triangle whose values are this length is x, this length is y, this length is r. So x and y are the components of this vector in the case we have here. So here x equals 20 and y equals 15. Okay. The length r you can get from Pythagorean theorem. And this angle theta, that's related to all three of these lengths. And there are three trig functions that you need to know. The first is tangent. The tangent of the angle is equal to the opposite over adjacent. The second is the sine. The sine of an angle is equal to the opposite or the hypotenuse. And finally, the cosine of the angle is equal to the adjacent over the hypotenuse. These latter two we use a lot in a related form where we'll write y equals r sine theta and x equals r cos theta. You just have to remember these.